Right. So, initial side, terminal side, and vertex. Those are, like the three main components of an angle. Now, when you have an angle, basically that angle can just exist anywhere in space. However, when you take the angle and you put it on top of the coordinate plane and you align it so that the vertex is at the origin and the initial side is lying along the x-axis, we say that that angle is in standard position, right? So vertex on origin, initial side on x-axis. That's when the angle is in standard position. Once we have the angle in standard position, now we can start to measure it and we can do all sorts of math with it. All right. How do we measure an angle? Well, you have your initial side, right? Right here. That's when, you have no angle. If you just have the initial side, you have no angle. You have 0 degrees. And then you sort of start rotating your second ray, which is going to become the terminal side, in the counterclockwise direction. So counterclockwise against the direction of the hands of the clock, going to the left. In math and physics, that's always the positive direction, the preferred direction. So when you start rotating along in the counterclockwise direction, you create a positive angle. All right. So for example, like in this case, this could be an angle of, let's say, 200 degrees. All right. Now, you can also start from that initial side, but you can be a rebel and rotate in the clockwise direction, right? From the bottom up. Like in that case, you are creating a negative angle. All right. Any questions here? Okay, so from the initial side, if you go up, positive. If you go down, negative. Okay, what units are used to measure angles? Anything that you measure in this world, you need units to express your measurements, right? How tall are you? So many meters, so many feet, right? How hot is it? 120 degrees Fahrenheit, right? Last weekend, right? So we need units for everything. Well, for angles, we have 2 units. First is the degree. All right. Now, if you start on an initial angle, on an initial side, right? And then you go around a full circle and come back. How many degrees have you gone? 360. Absolutely. So 1 degree is defined as 1/360th of a full rotation. So let's think about this for a minute. Suppose you order a pizza, right? And normally like they cut the pizza, they slice the pizza into what, 8 slices, right? So suppose you call up Domino's and you're like, hey, I want to order a cheese pizza, a large cheese pizza. But you know what? Instead of slicing it into 8, can you please give me 360 slices in my pizza, right? So now imagine a pizza sliced into 360 slices. How thick is each of those slices? Minuscule. That is 1 degree. Right? So that conceptually, that's how 1 degree looks. It's a very, very tiny sliver, right? So that's what 1 degree is. Now, so if you look, right, you know how the degrees are oriented in a circle. You have 0 degrees here, and then we know that if I go half the circle, I've gone 180 degrees. And then full circle is 360 degrees. Now, this is going to be important when we talk about radian. Let's talk about radian for a minute. Radian is the second unit of measurement for angles. Just like we measure temperature in Fahrenheit and Celsius, same thing. Angles are measured in degrees and radian, and there is a very clear conversion between the two of them. All right. So Here we go. Suppose D. Toledo got a brand new track coach and he happens to be a math teacher, right? Or a math major. And he says, you know what? I want us to build a track, but because I'm a math person, it needs to be completely circular. So now suppose we have a track, right? Like for track and field, but it's not oblong like you see in like normal places. We have a completely circular one, right? All right. So now suppose your coach now, so this is our track right here. He makes you stand right here. All right. And you guys measure the radius from the center, right, to the edge where you're standing. And suppose the radius of this is 10 meters. Okay? Now, he puts you right here. He slaps a pedometer. He doesn't have to put anything on you. You have your iPhone and your Apple Watch and everything. And he says, okay, start walking. And you're going to walk the same distance along this circle as is this radius. So the radius is 10 meters. He gets you to start walking this for 10 meters, right? And then suppose as soon as you get to 10 meters, something beeps and you stop. So now you're here and you've covered 10 meters. I know my drawing doesn't seem like it's to scale, but let's just go with it. Okay? Now, you have walked a length of 10 meters, right? So now if we were to take a ratio of the length that you have walked, we're going to call that S, over the radius R, right? You walked 10 meters. The radius is 10 meters. What does that give you? What's that ratio? 1. What does that mean? That means that this angle that you've created, that has a measure of 1 radian. All right? So now, let's take this a little bit further. Now suppose he says, okay, keep walking. So he makes you walk a little bit more until you walk 20 meters. Okay? Now, what's your ratio, S over R? The ratio of how much you've walked over the radius. 20 over 10, that's 2. What does that mean? That means this is 2 radian. Okay? Now, get this. Suppose you continue walking. He's like, all right, keep walking. Now you walk 30 meters. There is a point to this, right? There is a point to this. Now you walk 30 meters. S over R is now 30 over 10, 3. So this blue is 3 radian. Now suppose you walk a little bit more to here and he just stops you and you're just tired and you want some water and you've walked 31.4 meters. What's your ratio now, S over R? 31.4 over 10. How much is that? You guys know. It's a magic number. How much have we walked? What's that ratio? 31.4 over 10. Yeah. It's 3.14. So here we've made an angle of 3.14. And where have we seen that before? Sydney says pi. So pi, right? So this is where pi comes from, right? Pi is not some whatever number. So this is where it comes from. It's the ratio of how much you've walked around the circle divided by the radius, right? And when you've walked half the circle, that ratio is always 3.14 or pi, right? So now, so now we know where that comes from, okay? All right. So now, going over here, a full rotation, right? A full rotation around a circle has a circumference of 2 pi r, right? So what does that mean? That means by the time you've walked a full circle, the distance that you've walked divided by the radius is 2 pi, 6.28, 2 pi, right? Okay, so 1 radian then, this is important, 1 radian then, right, is defined as S over R. It's how much you walked divided by the radius, S over R. Okay? All right. So, all right. What we're going to remember from this is this one thing. That first of all, 180 degrees is 1 pi. And 360 is 2 pi. And then that's how you're going to convert between degrees and radian. All right? Any questions? Okay. So, all right. So here to convert from degree to radian, I have 135 degrees here. To convert, oh, by the way, here, I always put this in here. It's from the book, right? And it says, you know, to convert, blah, blah, blah. And, you know, I think the book expects us to memorize this. But you know what my philosophy is? We never memorize anything. So I purposely put that in there to cross it out and to tell you that I don't want you to memorize anything. Because when you've memorized things, the minute you're stressed out, you just forget them, right? So now I have to convert 135 from degrees to radian. Here's what I do. Anytime I need to convert anything, whether it's in math or chemistry or physics, I do times a fraction bar. And what's the conversion between degrees and radian? 180 degrees is pi. So, in my problem, degrees is in the numerator. So in my conversion factor, degrees goes in the denominator, and pi goes on top. Now all I need to do is simplify, and I get 3 pi over 4.
It's like algebra 2.
It's just like algebra 2. All right, here, negative 30, I do times fraction bar. Degrees is on top, so I put it on the bottom. That leaves pi for the top. Negative pi over 6. And if we were to go in the opposite direction, same thing. Now, pi is on top, so it goes on the bottom. And 180 goes on top. Pi's cancel, 120. Same thing here, 180 over pi. And I get negative 135. So stop me if you have any questions here. Okay, so we talked about, so one thing every year I find lacking is students are okay with degrees, like you know exactly where 135 degrees is on the circle, you know exactly, you know the pi's as well. But when we go to decimals like 3.14, 6.28, you know, it's not as obvious. So remember pi is 3.14, right? So that's pi. Half a pi is 1.57. So on the circle, if this is 0, at this point, this is half a pi. And it's 3.14 divided by 2, 1.57. And then pi is here, 3.14. 3 pi over 2 is here, 4.71. They're very awkward numbers, right? And you don't have to have these memorized. And then 6.28 is here. But what I want you to be comfortable is, if you come across an angle, and we will, theta, let's say, is 1.17 degrees. You should know how big that angle is roughly, right? Is it in quadrant 1, quadrant 2, quadrant 3, quadrant 4? So you think to yourself, okay, this is half of pi, 1.57. So 1.17 should be about here. You see what I mean? Like, that's what I want you guys to at least be able to do. Any questions? Okay. How are you guys doing out there? You're awfully quiet. Are you guys with me? You're just tired. Anybody know of any good math jokes lately? No? Why did the polynomial plant die? You guys know that one?
Couldn't find the root.
Because it had imaginary roots. So you were on the right track, Matthew. Isn't that funny? That one, when I heard a couple years ago, I laughed for like 24 hours. Yeah. Okay. All right. If you ever hear a math joke, send it this way. And as I remember them, I'll toss them over to you guys. All right. Coterminal angles. Let's do this. Okay, so look. Suppose we had to draw an angle of 200 degrees, right? This looks like an angle that could be 200 degrees, right? I start from here, boom, 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 180, go a little bit more, 200. Okay? Now, I want to draw another angle in red of 560 degrees. Check it out. Boom. That's where I start. 560 degrees, I need to go all around. That's 360. And then how much more? 200 more. Right here. Whoa. I ended in the same exact spot. 200 degrees, 560 degrees, seemingly extremely different from one another, but their terminal sides are lying on top of each other. When this happens, we call them coterminal angles. Okay? What would be this angle, do you think? This blue one here. This is a negative angle. What's one possibility for that angle that's coterminal with all the rest?
160. Negative 160.
Negative 160. Right? So now I have my 200, and then the 560 is a positive coterminal angle with the purple, because it's a positive number that ends at the same place. The blue is a negative coterminal angle because it's a negative number that ends at the same place. Okay? All right. So now.
Why would it be negative 160? One more. Please repeat that final part again. I get the terminal angles, but why would that be negative 160?
So to go from here to here, well, the red part was 200, right? The red part here was 200, or the purple. And then that balance for the blue is 160 to make it 360. So if we go, but don't worry, I'm going to show you exactly how to find them right now. That's what we're going to do right now.
I cannot see that.
Good. Thank you. So what I was going to do next is show you exactly, is we're going to come up with a way that we can do it every single time. So if I have an angle here, all right, let's say that's, I go up, it's 20 degrees. How much from this point should I go around in order to get back to the same place? How many degrees?
360.
360. So if I go 360 in the positive direction or 360 in the negative direction, I get back. Now, what if I'm really having fun and I go 360 and another 360 and another 360? Hey, totally cool, right? So we can add multiples of 360 and get back to the same point. So to find coterminal angles, we add or subtract 360 or in radian 2 pi. Okay.
That's to find the coterminal angle?
Correct. So now take a look at this next one. It says identify all angles which are coterminal with the given angle. All angles, it means every single one. How many possibilities are there?
Infinity.
Like infinite possibilities. We're obviously not going to list every single one, so we know there's a variable in here somewhere, right? Okay, so to find all angles, I would have to take the 80 and add to it not just 360, but multiples of 360. And the way I write that is 360n. What does that mean? It means I can add to it 1 times 360 or 2 times 360 or 100 times 360. But I can also subtract 360, so I also do minus. And so this expression now, 80 plus or minus 360n, is all of the angles. It's an expression for all of the angles coterminal with this. Now, if I wanted to find one positive coterminal angle, I just take 80 and I add 360 and I get 440. And then for the negative, I subtract and I get negative 280, right? And you just have to be careful. Just subtracting 360 doesn't guarantee you a negative angle. The value that you get actually has to be a negative angle. All right? And then, so next, this one. So to find all angles, I do negative pi over 4 plus or minus, not 360 this time, 2 pi n. You guys are cool with the n? You know why the n is there?
Just to be clear, the positive and negative, the first one, those were only some of the coterminal angles, right? For positive and negative?
For the red ones?
For the red ones, right? Because did you say you can make multiple rounds due to the fact that there's a
right. And those multiple ones are expressed in the purple. The red just has one example of a positive and a negative. Yeah. So now if I wanted to find one positive angle, I would do pi over 4 plus 2 pi. And pi over 4 plus, oh, it's negative pi over 4, I'm sorry. Negative pi over 4 plus 8 pi over 4 is 7 pi over 4. And then for the negative, I subtract, and I get negative 9 pi over 4. Okay, so you want to know my my quick way of adding fractions and whole numbers? Here's what I do. I do a little loop. I take the denominator and I multiply by that whole number. 4 times 2 pi is 8 pi. And then I added to the other one. 8 pi plus negative pi is 7 pi, right? So 7 pi over the same denominator, all right? That's my cute little loop way of doing it. obviously, you know, you guys are sophisticated math students at this point. Listen, if you have your favorite way of doing things, it's cool. All right, so let's talk about arc length. Have you guys seen this before? You may have seen it, but not in this terminology. Do you guys remember seeing this before, possibly in geometry? All right, so arc length is a partial distance around the circumference of a circle, right? A partial distance around the perimeter of the circle. The formula, the way in which we find it, is S equals R theta. But now this comes from the definition of radian. That means theta has to be measured in radian. All right, that's the biggie. Okay, so these are usually like, I call them plug and chug, right? Pre-calc honors kids usually do very well with this. The only thing people forget is to convert to radian. All right, so here we want the length of the intercepted arc, S, in a circle with the given central angle theta and radius r, right? So I have theta and r. R is fine, but theta has to be converted to radian.
Pi over 1.
So theta is 125 times pi over 180. It's 25 pi over 36. Then you plug it into the formula. So that's 7 times 25 pi over 36. Now, if it's a part on a test where you don't have a calculator available, then you would just multiply 7 times 25, and that's 175 pi over 36. And the units are centimeters. This is the exact answer, and it's perfectly acceptable. And then if you have a calculator, you can put it in your calculator, and you can round it to 15.3 centimeters. And those, those squiggly equal signs, they mean approximately. Okay, how are we doing over there?
Does it always need to be centimeters for doing this type?
Well, the units that were given here are centimeters.
Oh, okay.
Yeah. Okay, and then area of a sector. All right, so imagine now you've got the same setup. You have a central angle. You see how it creates this area inside? The area of that is half r squared theta, right? So half r squared theta is, you find the area of that like pizza slice. So here it says find the area of the sector with the given central angle and radius. Again, you just have to make sure that you're in radian. That's pretty, like that's the only thing that you have to remember with this. Like I said, usually, my pre-calc kids do okay with this. So theta is 60 degrees times pi over 180, pi over 3. Area is half r squared theta. That's my formula. Am I going too fast? Yeah, no, yes. Am I going too fast? Sydney.
So I have a question. Did you say that this section was, why is it half of the, how do you know it's half of the?
Half r squared theta?
Yeah.
Yeah, so I didn't go over why. I'm just, making you guys trust me.
Okay.
Okay, so half r squared theta, and that happens very rarely. I usually want us to understand why, but this one, I'll let this one go. But it does have to do with the area of a triangle and stuff. So half r squared theta, this is half. Now we have 8 feet for the radius squared. Remember, this is area, we're squaring the units, times pi over 3. I'm just going to round it right off the bat. 33.5 feet squared. This is area. Units are big in Precalc Honors. Okay? All right.
What if we did exact?
Huh?
What if we did it in the exact form? Like, you know, it would be 32 pi over 3. I'm pretty sure that's what it equals, right?
Oh, that's fine. So if it hasn't specified what form to put it in, you're obviously free to choose. But if it has specified, then that's part of the points of the problem. Okay? Okay. Now, for homework, I always put this note on here. There is a part where it talks about complementary and supplementary, and students by this time have often forgotten everything that they learned in geometry. But remember, complementary angles add up to 90 and supplementary to 180. Okay? So